Okay, so for the longest time, we just totally dismissed Mercury, right? We thought it was just this dormant, sun-scorched rock. But let me tell you, the latest data paints a completely different picture. We are looking at a world of extreme paradoxes, a highly dynamic environment shaped by massive volcanic floods, permanent ice, and dramatic tectonic shifts. This is a planet that defies literally almost every expectation we had about the inner solar system. So, here's our roadmap for this explainer. We'll start with the messenger revolution, then move into mapping a complex world, cratering and degradation, the absolute unit that is the mighty Caloris, a shrinking planet, and finally, polar ice and hollows. Let's get right into it. All right, part one, the messenger revolution. For decades after the Mariner 10 flybys way back in the 1970s, we literally had a massive blind spot. We'd only mapped about 45% of Mercury's surface. We were basically guessing about the rest of the planet until NASA's Messenger spacecraft finally arrived, executing its initial flybys in 2008 before pulling off a historic, unprecedented orbit in 2011. And when Messenger got there, it did not hold back. Over its 4-year orbital mission, it beamed back a truly staggering volume of data. We're talking over 150,000 images before it intentionally crashed into the surface in 2015. With that massive flood of data, scientists could actually start piecing together what really happened on this weird little world. Moving on to part two, mapping a complex world. Using all those thousands of orbital images, scientists were finally able to stitch together the very first 1 to 15 million scale global geological map of Mercury. For the first time ever, instead of just looking at disconnected patches, we had a complete planet-wide framework to analyze exactly where all these different terrains were located. Now, if you look at the map, you'll see these intercrater plains everywhere. They make up the absolute largest mapped geological unit on the entire planet. But honestly, how they got there is still a profound scientific puzzle. Researchers are fiercely debating this right now. Do they form from giant impacts efficiently churning everything up, or are we looking at the remnants of an ancient era of intense, widespread volcanic eruptions? And the contrast between regions is just wild. On one hand, you have those ancient, battered intercrater plains with all sorts of crazy, varying surface textures. But then you have the smooth plains, and I mean smooth. They're barely cratered, they have extremely sharp borders with the surrounding terrain, and they cover huge areas, especially up in the northern hemisphere, because they were created by massive volumes of volcanic lava just flooding the surface. Okay, part three, cratering and degradation. So the messenger data actually lets us grade how old these craters are, almost like a visual timeline of planetary erosion. If you look at a fresh Class 5 crater, like Cooper, it's got these beautifully crisp, sharp rims. But then you look at older Class 1 craters, and they're just heavily degraded. They've almost no topographic relief left because they've been pounded and overprinted by so many later impacts. But here is where things get really mysterious. When scientists analyzed the entire globe, they realized there were significantly fewer of those mid-sized degraded Class 1 craters than anyone expected. Think about what that means for a second. It implies that Mercury's absolute oldest record of impact bombardment wasn't fully preserved. Somehow, those earliest scars in the intercrater plains were wiped completely clean, or basically paved over. Which brings us to part four, the mighty Caloris. We absolutely have to talk about Caloris. It is a total monster of a basin, clocking in at roughly 1,500 kilometers across, making it Mercury's youngest large impact basin. But the crazy part isn't just the size of the impact, it's what happened after. The interior didn't just stay a shattered, empty bowl. It was later completely flooded by expansive, smooth volcanic lavas. And today, the whole thing is surrounded by incredibly complex tectonic structures and towering peaks. All right, part five, a shrinking planet. As it turns out, Mercury is literally shrinking, and this all comes down to its uniquely massive iron core. Mercury has a disproportionately huge iron core for its size, and as that giant metallic heart cooled down over billions of years, the entire planet contracted. Imagine an apple drying out and getting all wrinkled. That is exactly what happened to Mercury's crust. It created these massive thrust faults, known as Lobate Scarps, where one enormous block of crust was just shoved right up and over another. And we are not talking about tiny, superficial cracks here. We're talking towering, jagged cliffs. Take Enterprise Rupes, for example. It runs for over 1,000 kilometers and is 3 kilometers high. There's also Carnegie Rupes, which dramatically slices right through an older impact crater, and Adventure Rupes, which Messenger captured in stunning 3D stereo imagery. These definitively prove that Mercury's surface has been dynamically shifting and crumpling under massive tectonic stress. So, okay, we've got a shrinking, crumbling planet with a surface that is absolutely scorched by the sun. Which leads us to the ultimate paradox of this whole explainer. How on Earth, or, well, how on Mercury, could a place hot enough to melt lead possibly harbor water ice? Let's answer that in part 6, Polar Ice and Hollows. It all comes down to the planet's tilt. Or rather, the complete lack of it. Mercury has virtually zero axial tilt, meaning it has 0 seasons. Because of this, there are deep craters at the extreme north and south poles where the sunlight literally never rises above the rim. In these permanently shadowed, freezing cold traps, water ice survives indefinitely. Just a stone's throw from the blistering heat of the sun. It's completely mind-blowing. And right alongside that polar ice, Messenger discovered another spectacular mystery that scientists just call hollows. These are bright, highly reflective, shallow depressions that look like almost nothing else we've seen in the solar system. Often found on crater peak rings near explosive volcanic deposits, these hollows strongly hint that volatile materials in the crust are basically just boiling right off into space when exposed to that harsh solar environment. When you put it all together, it's pretty clear that the Messenger data completely rewrote the textbooks. With its massive cooling iron core, vast volcanic plains, towering tectonic cliffs, and literal hidden polar ice, Mercury is far from a dormant rock. It is a highly dynamic masterpiece of extreme geological contrasts. Which leaves us with this final, thrilling thought. If the tiny planet closest to the sun can hide ancient volcanic secrets, massive tectonic shifting, and actual water ice in permanent shadows, what other impossible geology is just waiting out there to be discovered in the unexplored corners of our solar system? Thanks so much for joining me on this explainer, and remember to keep questioning what you think you know.